Hi everybody. This lesson will talk about how to create a startup sequence that tests each LED, motor, and sensor that we have connected to your ClawBot. So in order to do that, we need to first start by telling the robot what sensors, what motors, and what LEDs are plugged into which ports on the robot's microcontroller brain. Okay, so we'll do that up here in motor and sensor setup, but first an important thing to check is under the robot tab. If you pull down the robot menu, and you go down to platform type, your platform should be the VEX 2.0 Cortex. If yours says VexIQ instead of the Cortex, you come down here to Vex Robotics and pick the VEX 2.0 Cortex. If you're on IQ by mistake, you won't have the entire functionality that we talk about right now. You'll be missing some of the features that we're going to discuss. So if you find yourself partway through this and you see that you're not seeing the same thing on your screen that I'm seeing on mine, this is the reason why. You've got to come in here to platform type and pick VEX 2.0 Cortex. So once we've done that, we'll go up here to motor and sensor setup. We should have 4 tabs: standard models, motors, VEX 2.0 analog sensors, ports 1 through 8, and VEX Cortex digital sensors, ports 1 through 12. If you only have 3 tabs here, you've got to go back and pick the 2.0 Cortex platform like we just talked about. On the digital sensors tab, we're going to code in some of our LEDs. So the LEDs are considered digital sensors, and digital sensors only have 2 states, off and on, and off is represented by the number 0, and on is represented by the number 1. We'll talk more about that in a little bit. So in the first digital sensor port, we're going to put the red LED. So I'm going to do all caps RLED. That represents the red LED. I'm going to go to port 2 and type YLED as the identifier or the name of our yellow LED. And our green LED is going to go by the identifier of GLED. So we've got 3 LEDs. From the sensor type box, I'm going to pull down and pick VEX LED for each one. Oops, wrong one there. There we go. And then I'm going to switch over to the motors tab while I'm here, and I'm going to put in the 4 motors that we have. If you code it according to the directions in class, the left motor should be in port number 1. So I type out L motor, or even for shorter, LM. Every time you want to start or stop or change the left motor's speed, you'll have to type out whatever you put in here. So don't type a big long name like this is the left motor, because you don't want to type all that. So I keep it really short and sweet. LM is my left motor. In port 10 is my right motor, represented by RM. In port 6 is the claw motor. And in port 7 is the arm motor. And for the type, we'll pull down the box and we'll choose VEX 393 motor from the drop down. All of the motors are that same VEX 393. There are some additional settings over on the right as to whether or not to reverse the direction of those motors. We'll figure out all of the stuff over here when we test the robot in a little bit. So for right now, I'm just going to leave all of this untouched. I'm going to click Apply. You'll see a bunch of configuration statements pop up at the top of your code, so I'll click OK. And you'll see a note here that says code automatically generated by the RobotC configuration wizard. Don't touch or change, modify, or delete any of the code or any of the statements that are up here in the configuration statements. So that's all necessary to make the robot operate the way that we want it to. Okay? I'm going to drop down into the main task, and we're ready to get started with some coding. So I want to start by coding an initial condition. So when we power the robot up, we want to make sure that the very first thing the robot does is ensure that all the LEDs and all of the motors are off or stopped. So our initial condition is going to do that. To control LEDs, you start by typing the word sensor value. It's a capital S. Oops, I had caps lock on. Sorry about that. Capital S and a capital V, and it should turn blue when you've typed it out correctly. I'm going to use the square bracket, which is the key above enter on your keyboard. And inside the square bracket, I'm going to put the identifier of the sensor or LED that I want to control. I'll then do a space equals and space and put either a 0 to turn it off or a 1 to turn it on. So in this case, we want to make sure that the red LED is off. So we'll type 0. And at the end of every single executable line of code that we type, we need to terminate the line with a semicolon. That tells the robot that that's the end of that line, move on to the next one. So that turns the red LED off. So right after it turns the red LED off, I want to copy that statement. And I want to go to the next line, and I want to paste that statement in and modify it so it controls the yellow LED. Okay, just trying to save some time and not have to type out so much. You certainly can do the same thing on your computer and in your code. Copy and paste as much as possible to save yourself a little bit of time. So we've got the red LED turned off now, the yellow LED turned off, and the green LED turned off. Now we want to make sure all of those motors are off as well. So I'll go to the next line, and to control a motor, we'll type the word motor, which is lowercase. We'll open a square bracket and put the identifier or the name of the motor I want to control in the square brackets. So I'll start with the left motor. And then I'll set that motor speed equal to 0. Motor speeds range from a negative 127, which is full speed reverse, to positive 127, which is full speed forward, and any numbers in between. So about 63.5 would be half speed. You can't control a motor at a half a speed, so 63 or 64 is close enough to half speed. That gets the job done. And you can choose any other motor speed that you want. But so in this case, I want to make sure that the motor is off. I'm going to assign it a speed of 0, and I'm going to really quickly just keyboard shortcut Control C to copy that, go to the next line, Control V to paste, change my left motor to my right, do the same thing, for the claw motor, and the same thing for the arm motor. So now we've got 7 lines of code written, that turn the red LED off, yellow LED off, green LED off, and turn all the motors off right as soon as we power the robot up. So that there's no chance that the robot moves by mistake or does anything kind of crazy or out of line. So I want to pause in that state for at least a second. Remember that time on our robots is measured in milliseconds, so we're going to delay there for 1,000 milliseconds or 1 full second. And then that is our initial condition. We can code the rest of our startup sequence from there. So I scrolled up a little bit, and I'm going to put in a new line, and I'm going to skip a line so that there's a little bit of divided space between my initial condition and where the rest of the startup sequence begins. So the list of startup sequence requirements is in the Google Classroom. We'll do this just as an example. So we'll pop that up here. It says robot startup sequence as the title of the document, and there's a list of startup sequence requirements here. If your startup sequence requirements are different for your class or your project, then those will be listed there, or you can make up your own. But I want to start by turning the red, yellow, and green LEDs all on simultaneously, all 3 at the same time. So we've done this starting condition with all the motors and sensors off. We've put in the delay so that we've got that covered. And then we're ready to move on to the rest of the startup sequence. So I'm going to bounce back here to RobotC, and I'm going to start to code in the rest of that startup sequence. So to do that, I'm going to type out sensor value, red LED, equals 1. And by the way, I put the spaces in between and around the equal sign just because I feel like it's easier to see. And white space or blank space in RobotC doesn't compute. It doesn't affect the line of code at all. So this line runs the robot exactly the same way that does, even if I had a ton of space between the equal sign and the 1. So the microcontroller on the robot processes exactly the same way. So I'm going to go in here now, and I'm actually just going to copy my yellow and green lines of code from above and paste them in there and change the off to on. And I want to delay in this state for half a second. So all my LEDs are going to blink on for half a second, and then they're going to blink back off. So I'm going to copy what I've already got from above just to save myself a little bit of time. And I'm going to delay in that state for half a second. So now I want this to repeat 3 times. I can literally take this code and copy and paste it 2 more times so the LEDs blink on and off 2 more times. Or I can use the repeat function. So if I put in a new line and type the word repeat, inside some parentheses I'll put the number of times I want it to repeat. And then I'll go to the next line and open a curly brace, which is Shift and the key above Enter. And then I'll go to after the end of what I want to repeat, and I'll put a closing curly brace. And you see they don't really indent to the right place, but when you click up top to fix the formatting, it'll bounce them into the right place. So the repeat starts here. The code that I want to repeat, that curly brace is at the same indent level as the word repeat. And down at the bottom, the closing curly brace for the repeat is at the same indent level as the open curly brace and the word repeat itself. So this is the code that I want to repeat 3 times. So we've got that done. So then we just code the rest of our startup sequence. I want to just copy and paste as much as possible. I'll just skip forward to the entire startup sequence coded here in a second and give you a look at that. So I won't make you watch all of it. I'll be right back. So you can see here that I've got the rest of the startup sequence coded. It went from repeating those 3 LED blinks to putting the red LED on for half a second, and then turning the red off and the yellow on almost simultaneously with no delay in between, so it flips from one to the other. Does that for half a second, then goes yellow to green for half a second, and then goes back to yellow, and it leaves yellow on for the rest of the startup sequence. The remainder of the startup sequence is the left motor and right motor starting together, so the robot moves forward for a full second, then the robot stops, then the robot moves backwards for a full second, and then stops, and then it does its swing turn to the left, and stops, swing turns to the right, point turns to the left, stops, point turns to the right, stops, puts the arm up and stops, puts the arm down and stops, opens the claw and stops, and then closes the claw and stops. So I've got a whole lot of extra stuff in here, like when I'm controlling just the claw, I don't really need commands for the left motor and the right motor to stay stopped because I stopped them previously in the code up above. So I can streamline this a little bit yet, and I'll work on that. But to see if what we've written so far is good and if it would run on the robot, we would click the Compile Code button up at the top, and this checks our code for errors, and if there are any errors, it'll state them down at the bottom. So you saw it pop up down there. If I click it again, it pops up, it says there are no errors. If there are errors, they'll be listed there. Let's see if I can get that to stick around. There we go. So the errors would be listed here.